So how do you satisfy this query? What are we going to do? Well, if you open up the files that we've provided, this proj3 images folder, you'll see that we have a bunch of different pictures of the Berkeley area at different levels of zoom. So the first character of each file name refers to the level of zoom. So D0 is the most zoomed out. Then we have D1. There's 4 of these, which are the northwest, northeast, southwest, and southeast corners of Berkeley. So I have them actually here on the slide. And all of the images are always 256 by 256 pixels. They're just at different levels of zoom. So here's D0, here's D1, and then in turn, this image, there are 4 images that you can use that are the northwest, northeast, southwest, and southeast corners of that. And that happens recursively many layers down until we get to depth 7. So ultimately you have tens of thousands of images at all these different resolutions, and your job is going to be to identify the proper input files. So for example, if you give me a query box, I could go digging through all these files and find the ones that look kind of like what we saw on the previous page. Now, to understand the structure of these files, we've provided a little demo here called FileDisplay Demo. And so I encourage you to try this out. And you can type in one of the file names. For example, D0, X0, Y0. It'll tell you that's the entire world. It has this upper left lon, this upper left lat, LR lon, LR lat, distance per pixel, and so forth. If I look up, say, D4, X6, Y11, we find out that's this spot on the map. It has these coordinates, and ultimately, you want to have a really deep understanding of how these numbers are calculated, because that'll be important for you to understand how to identify the correct tiles. Now, I'm not going to go through it in detail, because that's part of what I expect you to try and understand, given all of this helper, or all these starter videos and spec. Now, one thing that'll be really important to understand in that math, which again, I'm not going to talk about at all, is to know that the top left corner of the entire world is this set of coordinates, and the bottom right corner is this set of coordinates. And the way you know that in your code is that if you go to the top of map server, there are these important constants, many important constants, but these are the ones you care about right here. So we have the root, which is the depth 0 map, its coordinates, and this is the size of each tile. Okay, so you'll want to make sure to use these at some point in your code. Okay, so let's talk about trying to satisfy the query. So the goal when you're trying to obey a query is to display the region of the world that the user wants at the resolution that the user wants. So in this case, we want to display images that cover the desired range, that box that we showed on this right here, at a resolution of at least 0.355 feet per pixel. We want that at the very least. So we can imagine trying to use D1, X1, Y0. This is the picture shown. It does actually include the query box, but it is very small. So in other words, like if I zoom out like here, you can kind of see that it matches that picture just a little bit. I zoomed a little too much. But obviously using this picture, D1, X1, Y0 is going to be too small. Okay, actually, let's go look at it. Let's see, that's not the one I want. Where'd you go? Other images? Yeah. No, these are the ones I wanted. Okay. Oh, geez. Okay. So D1, X1, Y0. Okay, so this image does include the entire region, but it is clearly way too coarse resolution. Okay, so what you could think about it is you could compute the lon DPP for this image, and you'll find that it's about 49 feet per pixel. And the slide goes through the math, but I'm not going to, and that'll be something for you to think about. But here the resolution is much too low. If I move my mouse 1 pixel, I've moved 49 feet. The user wanted 0.355, not so good. So what if we tried to use D2, X2, Y0? So this image, as you can see here, also includes the entire query region. However, even though it is higher resolution at about 25 feet per pixel, it is still way too low of a resolution. It's way too zoomed out. Okay, so this was the old version. We go in and zoom a little more, still not good enough. And so now a question for you I'd like to ponder is, what depth would be good enough? So 1 wasn't good enough, 2 wasn't good enough, 3, you have some sense of what the feet per pixel should be. So how deep do you need to go? I really want you to answer this question. Think about it, because if you can't do this on your own, there's harder problems to be figured out on your own later. So try it out. Okay, so my answer is that 9 is the answer that would work. So we can think about it this way. The resolution is somewhere around 49 divided by 2 to the d minus 1. Now this is not an exact expression. I expect you to figure out a more exact answer using all of the information I provided so far, but just for the purpose of our slide, we can estimate by 49 divided by 2 to the d minus 1. So if we look at d equals 8, we would get around 49 divided by 2 to the 8th, which in a calculator we can find as 0.38, and that is not enough feet per pixel to satisfy the user's request. If we go to d equals 9, well, in that case, finally we get to 0.19 feet per pixel, and the user would be happy. Now, the bad news is that the data set we provide does not go to d equals 9. It only goes to d equals 7, and that's because, well, I mean, we got to stop somewhere, okay? And so what we're going to do, if the depth that the user wants is ever so deep that we can't actually satisfy their desire for incredibly high resolution data, we'll just give them 7 instead. Okay, so now that we know that we want depth 7, the question is, what images do we need? Well, let's consider the file d7x84y28. Okay, why this one? Well, I did some hard math at some point and decided that's which one we're going to talk about. But if you look here, you can see that's actually one of the ones we wanted. Okay, let's play jigsaw puzzle real quick. So remember that what we're trying to do is an image that looks something like this. Well, guess what? We found it. There it is. Hooray. Okay, so that's this top corner. And again, I didn't explain to you how I got that image, but that's part of what you're going to have to figure out. Okay. Now, supposing we determined that this is a useful image, is it something we could use on its own? Well, it has a good resolution. I mean, it doesn't quite satisfy what the user wants, but this is as good as it gets. But the bad thing is that it doesn't cover the entire query box. So remember, there's 2 critical requirements. 1, you need to fill in the entire user request, and 2, you have to give enough resolution if possible. So while we satisfy enough resolution, I mean, insofar as we can, we have not covered everything the user wants. If you look at the coordinates of the user's top left and bottom right here using FileDisplay Demo, you will see that it does not satisfy the user's request. Okay? So, what's the correct answer? Well, it turns out that these 9 files here, those will work. And together, those images will cover the entire space. Now, actually, as you notice, they actually cover a bit more space than what the user requested. If we look at the top left corner of the top left image and the bottom right corner of the bottom right image, it's actually just a little tiny bit bigger. And as a result, we end up, but actually, sorry, not as a result, but it turns out that's okay because the web browser will handle this for us. Okay. All right. So ultimately, here's the picture. This is what you got to do with rastering. The user wants to see everything in a certain region of the world with a certain level of resolution, and you are supposed to return these images. So the last thing I want to talk about here in this video is how do we actually specify this information? What does it look like? Well, this is all in the spec, but I'll shortcut you a little bit and say, okay, well, if we go looking deeply at Rasterer, we could see this is exactly what the program is expecting. You need to give me a render grid, a raster URL on, raster query success. And so if I set all of these things in this map that I'm returning, then the web browser will be able to interpret that and display something. So the return value, since we know what the answer is, and in fact, I mean, if you want just to figure out how everything works, you could just hard code this directly into your get map raster and show that it works. Like you just take this information and hard code it into the map, and you should actually have it work. And the ultimate, all the parameters that you need to provide, I mean, we have to give it the top left corner of the top left image. Okay, so that's this right here. And we need to give the bottom right corner, LRLAT and ULLAT. And that's important so that the web browser knows how much to clip. But the most important part is actually this render grid. And that's which images to display. And it's going to be a 2D string array. So this first array inside this array of arrays of strings is 3 images, and that represents the top row. So we see x84, x85, and x86. So x84, x85, x86. That is the most important part of what your program is going to generate. But don't forget, you also need to provide this other meta information, including the depth, including the coordinates of the top left and bottom right, and also including query success equals true, if indeed it was successful. So I hope that gives you a lot of room to get started. I think with this, you should be in good shape. It's not a trivial problem by any means, and it may take you a day or two from here to figure out how to do it. Because figuring out, I mean, the big unknown was where did this magic 84 and 28 come from? And that's going to be one of the main tasks that you'll need to figure out. Now, one last thing I want to point out, I mean, I've shown it already, but you really don't want to miss this file display demo because I think that will help a lot in terms of figuring out how one can compute these magical numbers that I was able to come up with. Okay? And even if you're not quite ready to start coming up with an algorithm, you can at the very least use this to start understanding the structure of the input files. Okay, so good luck from here. You should be good to go in terms of getting going on rastering. That was a lot of the word go in one sentence. So good luck, and I will see you in the next video.